Okay, so we're going to look at the last section that we'll be covering this year, partial fractions. And I'm sure you're going to love this because it involves fractions. So really quickly, I'm just going to demonstrate how to add fractions with variables, because what partial fractions means is you will be taking a fraction and deconstructing it and putting it into several fractions that add to get that final fraction. And you're thinking, what's the point of that? Well, when you get to calculus and you do integration by parts, you'll need to know how to do that. So it will eventually come back and you will see it if you do have to take calculus in college or next year as a senior. So when we add fractions, again, you have to have common denominator. So what you look for is, you take your denominators and you see, let's start with this one. Does x divide evenly into x plus 1? No, it doesn't. And does x plus 1 divide evenly into x? No. So these two together will be my common denominator. So my common denominator will be x times x plus 1. So I have to get a common denominator. So I look at this denominator, and this is the new common denominator. So I see what's missing is the x plus 1. So I multiply the denominator by x plus 1. So I have to multiply the numerator by x plus 1. So then I'm going to go ahead and distribute. 2 times x plus 1 is 2x plus 2. And then I look at my denominator here, x plus 1, and it needs to be this. So I know I need to multiply the bottom by x, which means I need to multiply the numerator by x so that I keep that fraction equal. So really I'm multiplying by x over x, which is 1. So 3 times x is 3x. Whenever you're adding fractions, the denominator stays the same, and you just add the numerator. So you're just going to combine like terms. So you have 2x plus 3x, which is 5x. And you just have plus 2. There's nothing else to combine with. So that would be my final answer when I add those two fractions together. So what we're going to be doing is they're going to give you something that looks like this, and you're going to find out the fractions that add to get that final fraction. So I'm going to do this video in several different ones because this is a pretty lengthy section. So I'm going to do this next example, and then I will start a new video. So the first thing you need to look at is your fraction an improper fraction? So that means, is my denominator larger than my numerator? So you're looking at the degree. So you're checking for the degree. If your numerator has a higher degree than your denominator, you're going to want to divide. That's not the case here. So the next thing you're going to do is you're going to factor your denominator. Again, all those questions on all those quizzes that we took that were review on factoring, this is why factoring is so important. It comes up in everything we do in mathematics. So if I factor this, I get x factors of 6, it's subtracted 1, so 3 and 2, it'd be a negative 3 and a positive 2. And then I write the fractional equation. So that means my two fractions, like if I'm looking here, my two fractions, one will have a denominator of x minus 3, and one will have a denominator of x plus 2. So what I'm going to do is I'm going to write this fraction over here on the left side of my equation, because these are going to be two equal fractions. So I don't know what this number is that's going to go over the x minus 3 factor, plus I don't know the number that's going to be over the x plus 2 factor, so we're going to use a and b. So that's step 3, write the fractional equation. So I take my original fraction, and it equals to this new fraction where we have to find a and b. Now, the reason I use a and b is because these factors have a degree of 1, so x to the first. We'll look at when these factors are repeated, meaning you may have an x to the third to the second power as part of your factor, or your actual factor has a squared x in it, and that's going to be different with what you put up here. So we'll talk about that when we get there. So the next step is we want to get rid of the fraction. So we're going to multiply both sides by the least common denominator. Well, the least common denominator is going to be this, which is what this is. So if I multiply both sides by that, that means I'm multiplying every term by that. So I'm writing that up at the top, x minus 3 times x plus 2, x minus 3 times x plus 2. And then what happens is this is that, so these will cancel, and I'm left with x plus 7 equals x minus 3 divided by x minus 3 will cancel, so I'll have a times x plus 2, which is, I'm just going to write a times x plus 2, plus, over here, the b over x plus 2, the x plus 2's will cancel, and I'm left with b over x minus 3. Now, we're going to use substitution to find the value of a and b. So this is going to, in this case, we're going to substitute two values in for x. And so there's smart values to plug in for x. So if I look at this factor, x plus 2, if I plug in a negative 2 for x, that's going to eliminate this particular factor, and I will be able to solve for b. What I mean by that, so I'm going to, this is how I'm getting this value. So I take x plus 2 and let it equal to 0, so x equals negative 2. So I'm going to let x be negative 2 in this entire equation. So negative 2 plus 7 is 5. And then I have a times negative 2 plus 2 plus b times negative 2 minus 3. So I have 5 equals negative 2 plus 2 is 0. 0 times a is nothing, so this is gone. And then I have negative 2 minus 3 is negative 5. This is negative 5, so negative 5b. And then I solve for b, and I get b equals negative 1. Okay, so that's the value of b. Now, to find the value of a, I look at this factor that's associated with the b. And if I take x minus 3 and let it equal 0 and solve for x, I get x equals 3. So now I'm going to let x be 3 back into this equation. So I'm going to let x be 3 here. So I have 3 plus 7 is 10. I plug in 3 here, so I have a times 3 plus 2 plus b times 3 minus 3. So I have 10 equals 3 plus 2 is 5 times a is 5a. 3 minus 3 is 0. So 0 times b is 0. So I'm left with a equaling 2 because I divide both sides by 5. So now I have a. So now my final thing is to show that x plus 7 over x squared minus x minus 6 equals a, which is 2, over x minus 3, and b is negative 1, so minus 1 over x plus 2. So this is my answer. Actually, this is my answer. This is my partial fractions that equals this original fraction.